Alright, in this video we're going to talk about how we can code for our first group, or the randomized by student with pre-test, post-test data. This is going to be the majority of the intervention group designs that we're going to look at, so I thought it would be a good place to start. So the first thing that we want to do is we want to go ahead and provide the study name. So in this case you want to put the first author's last name and then the year it was published. So this, I'm going back to my same old Bryant et al. 2021 article that is a good article, just came out a little too recently. And then Sarah Powell went ahead and numbered all of the studies for us. So this study ID is number 143. When you download your articles to work with, they are all numbered and they're just labeled as such. So that's not a hard number to find. If you have any questions, go ahead and let me know. Go ahead and not mess with this column yet. We're going to have to go back and manually figure out the effect size ID after all the coding is done, so you don't have to worry about that one. For comparisons, what we're looking at here is, are you comparing treatments to control? If there's multiple treatments, then it might be treatment 1 versus control, treatment 2 versus control. So it's sort of every comparison that the article looks at, we need to take into account when we're coding. So for us, they're only comparing one treatment group to one control group. So I'm going to go ahead and put treat 1 versus control, treat 1 versus control, and treat 1 versus control. Okay, if you had, let's say, a treatment 1 and a treatment 2, what you would do there is you would want to take into account treatment 1 versus control on the TEMI PM, and then you would want to add in another row above and say like treatment 2 versus control also on the TEMI PM. So for every sort of comparison, we want to calculate that effect size. So for everything that they measured, we want to make sure that we take that into account. If for whatever reason they measure treatment 1 versus treatment 2, they might, I'm not quite sure why, then you would include that as well as an additional comparison. This doesn't happen a ton in math interventions. I think it happens more often in reading interventions. But if you have any questions, go ahead and just reach out and we can help you with that. So now that I have my study ID number, I have my 3 comparisons, I'm now going to start coding for the effect size, which is super, super fun. We're going to say it's super, super fun. If we keep saying it often enough, maybe it'll be super, super fun. So when I'm looking for my coding information for effect sizes, I'm probably going to have my best bet either looking in the methods section or looking more likely in the results section. And typically the best place where you can find a good chunk of this information is going to be in your results table. That's always kind of my happy place to go to when I'm looking for coding this kind of information. And the way that we structured these coding sheets is, you can see here, this is called data option 1. Most pre-test, post-test, randomized by student studies will include the following information. They'll have a post-test mean for the treatment group. That's what that means. They'll have a post-test standard deviation for the treatment group. A post-test N is the sample size, so a post-test sample size for the treatment group. They'll have a pre-test mean for the treatment group. They'll have a pre-test standard deviation for the treatment group. They'll have a post-test mean for the control group. You guys catching a pattern here? A post-test standard deviation for the control group. A post-test sample size for the control group. Pre-test mean for the control group. Pre-test standard deviation for the control group. Pre-test sample size for the control group. And then what we're hoping they have is either a p-value for when they compare pre-test to post, or excuse me, when they compare the treatment group to the control group, or what would be really cool but most studies don't really tend to have it, is this is looking at the correlation between the pre-test and post-test. It's so rare to find, so if you do find somewhere where it will just be described as pre-test, post-test correlation, I haven't seen it identified as anything else. If you find that, let me know, because you deserve a gold star for the day, because they're so hard to find, and they're just not reported that often. But let's say your study doesn't include this information. Let's say you don't have all that you need to fill in these blue boxes for data option 1. Then what we're going to ask you to do is look to see if you can complete data option 2. And we'll look at what that looks like in a minute with another study. But hopefully, if you can fill out all the information in data option 1, then you can stop. You don't have to do data option 2 if you have all your blue boxes complete. If you're good, you may stop here. Only go to data option 2 if you cannot fill in all the information in the blue boxes. So let me walk through what this looks like for the Bryant et al. Study, and then I'll walk you through what it looks like for maybe a study that doesn't have all of our blue box options, information, and how we're going to deal with that. So for my Bryant et al., I'm going to look here in the results table, and I'm starting with, let me make sure I'm starting with the right measure, my TEMI, PM, total score, progress monitoring. Yeah, TEMI, PM. Okay. So now that I have that, I'm going to look for the post-test mean for the treatment group. So a lot of this is going to just be being very careful that you find the right, the right group. So now it's post-test standard deviation of the treatment group. Yeah, so I don't even know if I should be talking while I'm putting this in. If I make a typo, it's going to be really embarrassing. But, okay, post-test sample size of the treatment group. You can see, hopefully, most studies include all of this information for you. Pre-test, mean, treatment group. And I think there's been a big movement just to put these all in tables because it makes everyone's life so much easier. Pre-test standard deviation treatment group. Yeah. Pre-test sample size treatment group. Those of you who know me know I'm not a great multitasker, so I was going to go through and do all of these just to show you. Post-test, mean, control group. I don't know if that's helpful at this point or if you're like, okay, we got it. Post-test, standard deviation, control group. I'll do it for one measure. How about that? Just to show you all this information. Post-test, sample size, control group. And the reason why we're having you put in all this information is because it will help us later, pre-test, mean, control group, when we are doing the analysis. When you have all this really great information, we just plug it in and can run it real fast. Pre-test, standard deviation, control group. I literally have to go back one at a time. Make sure I got all these. Pre-test, N, control group. Okay, so that's the really easy part. And that's the key stuff. That's super, super important. Now, the next thing that we're looking for to see if they have it, this sort of makes our life easier, is we're looking for either the p-value of the test when they're comparing treatment to control group, or we're looking for a correlation pre-test, post-test. You're welcome to read through the whole article. I recommend you do. I'm going to go ahead and put in correlation in my find button. There's nothing there. I've skimmed this. There's nothing on the correlation. You can look sometimes for like pre-test, because usually it'll say like pre-test, post-test like this. So if you look through the pre-test options, all this is sort of where it falls within the study. So nothing about the pre-test, post-test correlation. Like I said, if you find that, it will say pre-test, post-test correlation. So since I can't find that, I'm going to look to see if I can find a p-value of the test on the TEMI PM. Sometimes it will just be here in the table itself. It will just sort of run down p-value sort of when they evaluate it. But I'm going to have to go into the narrative, and I see here there was a statistically significant difference between treatment and comparison group on the TEMI-PM total score. That's my beta standard error, p-value of 0.00. It probably wasn't really 0.00, but that's the only thing that we got. So I'm going to go ahead and put in 0.00. So it comes up as 0. That's a little problematic, but it's the best that we have, so we're going to go ahead and stop there. So if you have all of this information, then you can stop with the blue box. You don't have to go on to the yellow. We're going to imagine, because you are all very smart, intelligent people, that I went through and I filled out the second row about the TEMI-O, and that I filled out the third row about the Stanford. It will be very similar. You just go through the results table in the same way. You would go probably in the narrative to look here. So like for this one, let's see, so right here, when it's talking about the Stanford, then it shows the p-value is 0.51. So that's a much better, or like the p-value of the TEMI-O is 0.50. So that would be a much lovelier p-value for here, much more precise than 0.00, which we're like, that's a little problematic. But that's to show you better p-values. So let's say your study doesn't have some of those information. What do you do then? So I pulled up here, I pulled up a study by Botke, and he uses an Anova. And let me read through real fast to make sure we have the right information. Okay, so bear with me. I pulled the wrong study, but we're going to pretend that it includes an Anova instead of a Anova. They're going to look very similar. The hard part is it's just a lot harder to find studies that use ANCOVAs. So the difference is you can see here, when it looks at the results, they use an Anova, which is just an analysis of variance. So it's just sort of when you have multiple groups, instead of running a bunch of t-tests, you can run this big test all at once, just to see if there's any differences. And then if you have an ANCOVA with that C, then you include a covariate. I believe it's the pretest you run as the covariate. It will look just like this, except it will have a C instead of no C. So I apologize for that. Bear with me, just because this is going to be similar enough that I wanted you to see what you would look for if you couldn't find that lovely information that we found in the Bryant et al. So let's pretend you couldn't find all that nice stuff from the Bryant et al. Instead, you might have to go into the study itself and find the sample size of the pretest, the sample size of the post-test and of the treatment groups, the pretest and post-test sample sizes, and then you're looking for what's called the F statistic, which you can see right here is reported like this. F equals 64.43. And what you're looking for is you're going to look for the main effect, because since it's a big test, it tests lots and lots of things, and you're looking for the main effect F, which is right here. As I was rereading this real fast, what I did notice is this is the main effect for test wave. This Botke study is kind of a peculiar study in that he measures the students over multiple time periods. And so when you're looking at an Anova or an ANCOVA, what it's doing is it's testing everything all at once. So it's testing whether or not there's a difference between the treatment and the control, and then it's also testing whether or not there's a difference between the pre-test of everyone and the post-test of everyone. So it pulls things together and then sort of tests those effects. So here, what I originally highlighted the main effect for test wave, that's actually looking at across time if there was a difference between pre-test and post-test for everyone. And that's not what we're really interested in. What we're interested in is whether or not there was a difference between the treatment and the control students. So what you're going to see is you're going to look for something that reads kind of like this, where it says the main effect for the type of instruction. It might be main effect for intervention group, so whether or not they're in the intervention or not, because you're kind of looking for whether or not there's a difference in scores depending on what group you're in, depending on whether or not you receive the intervention. So the F score that I'm actually interested in is this one down here. So you can see it's much, much smaller. It's just 0.81. And you can see, whoops, this score is not statistically significant, but what we are interested in here is whether or not the p-value is going to be positive or negative. And what I mean by that is not really the p-value itself, but whether or not the difference is a positive or negative difference. So you can see here 0.81 is going to be a positive difference. And I was having trouble earlier with the Excel format in that when I have just a plus sign, it thinks I want to add in a formula. So I'm for now just going to put positive. If I come up with a solution by the time that we have our next meeting, I'll share that with y'all. But you're just going to put positive because our effects show that there was a positive but not statistically significant difference between the treatment and the control groups. And then going back here, just a few things that I want to mention. I breezed through them earlier, but a lot of studies may not necessarily report both the pre-test and post-test sample size, especially if they don't keep track of that, or if for whatever reason they don't want to admit their attrition rates or anything like that. A lot of times you'll just have one sample size that they provide. If they only provide one sample size, go ahead and put it in both boxes. But if they do include both sample sizes, that is always better if it is more precise that way. So you can see here, this one's, again, like I said, kind of an odd study because he's testing at different times and sort of if like the order matters. But you can see here, pre-test sample size, post-test sample size is the same, for this measure at least, for both groups, for both sequence A and sequence B. So I would put, I would read the study, figure out which one is the treatment group. I would put their sample size that it matches. Maybe we'll say sequence A was the treatment group. You would have to read through the article to find out. So I would put, 38. The control sample size is 42 and 42. And this is the only column that doesn't need to be filled out. If you can find it, then give yourself a gold star because they're really, really hard to find. But if you find something that talks about the correlation between the pre-test and post-test scores, go ahead and include that information as well. So that was an example of how to code for randomized or studies that include randomized by student measures that have pre-test and post-test. So just to recap real fast, what you're going to want to do is you're going to want to make sure that you code all of this information for every one of the measures that you have, as well as every one of these sort of comparisons. So you could see for here, for this study, instead of treatment 1 versus control, I would actually have, I think they're both active, so it would be treatment 1 versus treatment 2, in which case, when it had the Anova instead of the control group, I would have put, like this still same treatment 2 group. So what is it compared to? So make sure that you include all the information for every comparison and every measure that you are looking at in your study. If they have this descriptive data, this is the best data if you can fill in all the blue boxes except for maybe the correlation pre-post score. That's ideal. If they don't have it, and they include an Anova with the C, Anova score, then you can go ahead and put in that information. If for any reason your study doesn't report this data, maybe it has a really sophisticated analysis and it's hard to determine what the numbers mean because maybe they're not reporting this lovely descriptive table, but they have all these sort of crazy letters and models and things like that, just reach out and I can always help you sort of figure out what information they are providing, and we can figure out what we need to collect in order to figure out our effect size. So I hope this was helpful. If you have any questions at all, please feel free to reach out. I know sometimes the statistics can get kind of crazy because everyone reports it in different ways, but hopefully all of your studies will just have one beautiful results table and life will be super hunky-dory simple.